Have you ever stopped and wondered how your email magically knows what's junk? Or how a website can just spit out a pretty accurate price for a house? Well, the secret sauce is often a type of AI called supervised machine learning. And really, it all boils down to two main jobs: being a sorter and being a predictor. So let's dive in and see how it all works. Okay, so let's start with the big question, right? How in the world do you teach a machine to think? It sounds like something out of science fiction, but the main idea is actually something we're all really familiar with. Honestly, it's a lot like teaching a child. Think about it. A kid learns from experience. They see a dog, you say dog, and after seeing a bunch of different dogs, their brain starts to get the pattern. Well, machines learn in a very similar way. Their experience is just what we call training data, and we feed them tons and tons of it. And this brings us to the main event, supervised learning. That word, supervised, is the absolute key. It means the machine gets to learn from data that's already been labeled by a person. It's like we're giving it a giant stack of practice questions, but we're also giving it the answer key, so it can see the question and the right answer over and over until it learns what the correct patterns look like. And this isn't just us making up a nice metaphor. It's really how folks in the field think about it. The human expert is the teacher, providing all that labeled data, and the machine is the student, just soaking up all that knowledge. Okay, so this diagram lays it all out for us perfectly. See on the left? You start with your bucket of labeled training data. You feed that into the learning process. And what comes out the other side is what we call a prediction model. You can think of this model as the finished product. It's the brain that's learned all the important patterns. Now it's ready to go. You can give it brand new, unlabeled stuff, and it can make a really good guess on its own. So, our machine has done its homework. It's studied the answer key, and now it's ready for a test. But what kind of test? Well, this is where we get to a fork in the road, because all that learning prepares the machine for one of two very different jobs. And here's that fork, right here. Supervised learning splits into two main paths: regression and classification. Now, I know those words, regression and classification, might sound a little academic, but I promise the ideas behind them are super simple, and they're happening all around you every single day. Let's start with the first one. Our first task is all about sorting things into different groups. This is the job of what we're calling the sorter, and in the machine learning world, the official term for this is classification. So what's the goal here? It's simple: to predict a class label. Basically, the machine's job is to look at something new and put it into the correct box, a box that you've already defined. It's not creating new categories, it's just sorting. You see this all the time, right? The questions a classification model answers are usually a this or that kind of thing. Is this email spam or not spam? Is this tumor malignant or benign? Is my favorite team gonna win or lose? Does this photo have a cat or a dog? See the pattern? In every single case, the answer is just a choice from a very short, predefined list. All right, that was the sorter. Super useful. But now let's talk about that other path, that second job. This is about predicting a number. This is the job of the predictor, and the technical term for it is regression. Now, with regression, the goal is totally different. The machine isn't picking from a list of categories anymore. Instead, it's trying to predict a very specific number along a sliding scale. And just like before, the questions it answers tell the whole story. What's the price of this house going to be? The answer isn't just expensive. It's a specific number, right? Like $450,000. What's the temperature going to be tomorrow? How much corn will this field produce? All of these require a precise numerical answer. This scatterplot is a fantastic way to actually see regression at work. Each one of those little dots is a piece of data we already have. The regression model's job is to draw a line that best fits right through the middle of all those dots. Once it has that line, it can make predictions. So if we come along with a new flower and we measure its petal length, we can just trace up from that point to the line, and voila, it predicts the sepal length. It's using the pattern to guess a new number. Okay, so we've got sorting into categories versus predicting a number. It sounds pretty straightforward, but how do you really know which is which when you see it in the wild? Well, there's one simple trick to tell them apart, every time. The deciding factor is just one word: continuity. That's it. All you have to do is ask yourself, is there a smooth, continuous range of possible answers? That one question is the key. Let's put this to the test. Over on the left, you've got classification. The answer is a distinct category. An email is either spam or it's not spam. There's no such thing as being kind of spam. There is zero continuity. Now look at the right, regression.
The outcome is a number on a spectrum. A house can be priced at $400,000. It can also be $400,001 or $400,050. It exists on a smooth, unbroken number line. That is continuity.
So let's just boil it all down one last time with this table. For classification, the goal is to assign a category. The output is a discrete label. It answers questions like, is this a cat? Yes or no. For regression, the goal is to predict a numerical value. The output is a continuous number. It answers questions like, how much will this cost?
So there you have it, the sorter and the predictor. These two basic but super powerful jobs are being done by AI all around us, all the time. Now that you know the difference, here's a little challenge for you. As you go about your day, try to spot them. When you see a prediction, ask yourself, is it sorting something into a box, or is it predicting a number on a scale? You'll be surprised how often you see them.